to Educate Foundation YouTube channel. Today we want to look at Flownet. Before we solve the question, I would want us to go through the whole topic about Flownet. Now, when we talk about Flownet, it's a graphical representation of how fluid flows, and it follows it satisfies the Laplace equation. So, assuming this is our dam here, so let me change the color so that we can clearly see it. So this is our dam, and our dam is built on the foundation, right? So this is um, the soil. The soil, it can also be a rock. Now, behind at the upstream there is water, and downstream, this is the water level. This is the water level. Now, there is going to be flow of water from in this direction to this side. There's going to be a flow of water, right? And so Flownet is a graphical way of representing how this water is going to seep through the foundation of the dam, from the upstream to the downstream. So in soil mechanics, we want to actually look at a way of reducing this seepage, because this seepage will result in what we call the poor water pressure, which when not if the dam foundation is not designed well, it can cause the dam to rotate. It can even cause the dam to fail, right? So it's very important we understand the whole concept of Flownet or dam. Now, if you look at this diagram here, so this is the actual graphical representation of Flownet. Now you could see some lines, right? You could see these lines. So let me the how do you call it, the dark lines that you could see here. So this one, this ones, these dark lines, right? These lines are called the flow lines. The flow lines. So the flow lines actually um the space between two flow lines tells us the flow direction, or the channel that the water or the fluid will flow. So if I have a flow line here, it's telling me the direction or the path that the fluid will flow. So two flow lines, this is a flow line, one flow line, two, will give us what? A flow channel. So this is a flow channel, right? So if I have a flow path or flow lines, it demarcates the area through which the fluid will flow. So in this diagram, we have this the base of the dam will be a flow line. This will also be a flow line, and so between this line, it's not clear. Let me zoom in so that you could clearly see it. So let me use a different color. Let me use blue. So the base of the dam here is a flow line, right? Then this line here is another flow line. So between this line, let me call it one, and this line two, this space is a flow channel. So this flow channel, water will seep through. Then this line also is also a flow line or a flow path. Now between this that is 2 and 3, we have a channel. So this is also another flow channel, right? This is also a flow line or a flow path, and it creates another flow channel here. So, and the impervious layer down here, which is our clay, the boundary between this foundation and the clay layer, is also a flow line, and so it creates a flow channel here. So we have 1, 2, 3, 4. We have 4 flow lines. Sorry, 4 flow channels, and we have 5 flow lines. You get it? So the flow lines are simply the path, right? The path at which water can seep. So the base of the foundation can serve as one, and just as I've indicated, right? Yes. So those are the flow lines. So that is what a flow line. Now this, you could design this. Mostly this is done using computers, software. This software CWS. You know, you input the parameters and it will design the flow lines for you. You can also do it manually by drawing it to scale, right? So that is what a flow line is. So simply put, flow lines will tell us the boundaries at which the fluid or the water will seep. Now between two flow lines is a flow channel. You know what a channel is, right? Then we have what we call, so let's take note of the terms. So we have flow lines. So flow lines. Then we have flow channels. Flow channels. Flow channels. Now flow lines is the same as the flow path. Then the last one is called the equipotential line. Equipotential. Equipotential line. Now equipotential line is like an English word. Equi means equal. Potential is, let's say, energy, right? So equipotential line is that if we have 2 points or points that have the same energy, and here what energy are we talking about? We are talking about head, the head of the water. So if you have points that have the same head, they are joined by equipotential lines. So if you take an equipotential line at any point under the dam, they have the same head, right? And so you could see the broken lines in this diagram. Broken lines in this diagram are the so the equipotential line starts from here. So this is an equipotential line because at this point it's going to have a certain head because there is water here. So let me call this point E, right? There is water here. So at this point it's going to have a certain what? Head, right? Then so any point here, any point here on this line will have the same head. Then we come to this broken line 1 is also an equipotential line. So any point on line 1 would have the same head. So this point, let me call this B1, B2, B3. Let's take another point, B4, B5. All these points will have the same head, because they are equipotential line. So in this flow net diagram, we have 1, 2, this 2, we have 3, we have 4, we have 5, we have 6, we have 7, we have 8, we have 9, we have 10, 11, 12, 13, 14. So these are equipotential lines, right? Now the difference between two equipotential lines is what we call potential drop. So if I have two equipotential lines, because they have heads, for example, this equipotential line 0 has head of 10, and equipotential line 1 has a head of 9. Now you realize that it moved from 10 to 9. So between 10 and 9, there is what? A head loss, right? Yes. So the difference between two adjacent equipotential line is what we call potential drop or head loss. Are we okay? All right. So let's take note of it. The space between two flow lines is a channel, right? And the space between, or the difference between two adjacent equipotential line is what? Potential drop or head loss. So let's take note of that. Now, if we want to know the total number of drops, this is how we do it. It's either you count the equipotential lines starting from 0. So if you are counting the equipotential lines, you see the lines, these lines, you see they started from where? 0. If you want to know the total number of drops, that is ND, right? Which is very important. We need the total number. If I want to know the total number of drops, which is ND, I need to either count the equipotential lines by starting from 0, or I count the spaces between the adjacent equipotential line. So if I'm counting the spaces between adjacent equipotential line, let's see how many um, drops that we'll get. So let's count. So equipotential line, this is an equipotential line, this. So there's 1, this is 2, this is 3, this is 4, this is 5, this is 6, 7, 8, 9, 10, 11, 12, 13, 14. So how many drops? 14 drops. If I want to count the lines, the equipotential lines, I start from 0. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and what? 14. If you don't do that and you count using the equipotential lines and you start from 1, you end up getting 15. So this is what I do. The total number of drops is what? Is 1 less than the number of equipotential lines that you see. Or in simple terms, just count the spaces between the what? Adjacent equipotential lines. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and what? 14. As simple as that. Are you okay? So I believe by now you know what a flow line is, a flow path is, you know what a flow channel is, you know what a potential line is, and you know what potential drop is. Now, why are we doing this? We are doing this to determine the discharge, right? So the discharge under the net, the dam. So the discharge under the dam is given by the relation K change in head NF over N, where K is equal to permeability, the permeability of the soil serving as the foundation. Change in H is equal to total head loss. NF is equal to number of flow channels. Not number of what? Flow lines, but rather number of flow channels. So number of flow channels are the spaces between the flow lines. So in this case, we said this is a flow line, 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 this is a flow line. If you want to count the number of channels, is the space between adjacent flow lines. So this is flow line 1, flow line 2, flow line 3, flow line 4. You get it? That's the number of flow lines. And ND is total number of drops, or the number of drops. You get it? And that is how we used to find the discharge under a dam. I hope this video is useful to you and better explains the whole topic under Flownet. We will solve the question in the video coming up. Bye.